Welcome to today's lesson on naming of alkanes. There are actually some few steps we need to follow when naming alkanes. And the very first step is to find the longest continuous chain. So we are going to practice with some few examples to learn how to identify the longest continuous chain. And we are going to start with the simple ones. For this one, it is obvious that the number of carbon atoms in this organic compound is only 1. Since the number of carbons are only 1, or you have only 1 carbon atom present in this compound, the parent chain is going to start with METH. And this is not even a chain at all because it's only 1 carbon. For 2 carbons in the alkane molecule, the name is going to start with ETH. And this, the 2 simple ones we can actually start with. The next example we have is 3 carbon alkane. So the number of carbons in the longest continuous chain is 3, and the prefix for this organic compound is PROP. This is our next stop. If you take a very close look at this organic compound, there are 5 carbons here. 1, 2, 3, 4, 5. 5 carbons. But the number of carbons in the longest continuous chain are 4. Why 4? There are 3 different chains in this single organic compound. This is the first chain. This one is the first obvious chain. Then we have this as the second obvious chain. They have this as a third obvious chain. But which of them is the longest? This has 1, 2, 3. This chain has 1, 2, 3, 4. And this chain has 1, 2, 3, 4. So this and this have the same number of chains. And we are at liberty to choose any one that we want. But the point is the number of carbon atoms in the longest continuous chain are 4. And if that's the case, the prefix for the longest continuous chain will start with BUT. Next example. For this organic compound, there are actually 6 carbons present. 1, 2, 3, 4, 5, 6. But the number of carbons in the longest continuous chain are 5. So that means the prefix for the parent chain will be pent, P-E-N-T. More like pentagon, 5-sided figure. So pent. How did we get the longest continuous chain? We have at least 3 chains in this single organic compound. We have 1 chain, and we have another chain. I think we have and this chain. So if we pick from this side, 1, 2, 3, 4, 5. But if we pick it this way, 1, 2, 3, only 3. 5 is more than 3. And if we pick it this way, 1, 2, 3, 4, 5. It's still the same as the first one that we did. So we are at liberty to pick any one that we want. So we have 5 carbons in the longest continuous chain. There is something important I would like to stress on when it comes to identifying the longest continuous chain. In organic chemistry, in naming alkanes, there are certain times when the name of the organic compound will be written in this way. That is the open structure. So you might see it this way, or this way, or this. The third one is the condensed structure of the organic compound. But this, and this are all referring to the same compound. Why are we saying that? If you look at the open structure for this, we have 1, 2, 3 carbons here. It's the same as 1, 2, 3 carbons. For the first carbon, we have 3 hydrogens attached to it. For the first carbon, we have 3 hydrogens attached. For the second carbon, we have 2 hydrogens attached. Second carbon, 2 hydrogens attached. Third carbon, 3 hydrogens attached. So this is the open structure, but this is the condensed structure. The condensed structure is more like just removing the dashes, which represent the bonds. So CH3, CH2, CH3. So any of these 3 you find is basically referring to the same thing. And knowing how to find the longest continuous chain in one should enable you to find it in the other one. The same thing applies to this, and this. This are referring to the same compound. This, and this are also referring to the same compound. If we take a very close look at this open chain of organic compound, you realize that we have 1, 2, 3, 4, 5, 6. And in this structure, you have 1, 2, 3, 4, 5, 6. And this CH3, C and 3 H's you see here is this. And this one you see here is this. So this open chain is just written in a condensed form like this. This CH3 is this. This CH is this. The substituent CH3 is this. That's why I've changed the color to red. And I'm sure when you follow through, you would actually understand how the structure is gotten. Let's summarize what we've done so far. This table gives us a summary of all the prefixes depending on the number of carbons in the longest continuous chain. If the number of carbon we have found is only 1, then the prefix will be meth, meth. And that means that the parent chain will be methane. If the number of carbons are 2, we have eth. That means the name of the parent chain will be ethane. And for 3, we have propane, but for 4, butane. The same thing for pentane, hex, hexane, hept, heptane, octane, nonane, and decane. So it is important to know the number of carbons in the longest continuous chain, as this is actually going to give us the parent name for the longest continuous chain. Let's move on to the second step. Once you've identified the main character, which in our case is the longest continuous chain, it's time to give them some structure. Yeah, literally. And in doing that, we start numbering the carbon atoms from the end closest to the first substituent that we come across. So we're actually going to practice that with some examples. This compound here is the same as this. This is the same as this. CH3 is the CH3. CH3, CH3. But I'm going to use this one for the explanation of numbering the carbon atoms. So we have two options of numbering this carbon atom. We have option 1 as this, and we have this as option 2. For option 1, for the longest continuous chain, this is our longest continuous chain. This. And this is the substituent. So you have an option to number the carbons in this way: 1, 2, 3, 4, from the left to the right. Or we have it this way: 1, 2, 3, 4, from the right to the left. Which of these two numberings is the correct one? This is the correct one and this is wrong. Why is that the case? If you remember correctly, we said you start numbering the carbon atoms from the end closest to the first substituent you come across. And this is the first substituent. We want to do everything possible to give the substituent the lowest possible numbering. And in this case, the substituent is located on carbon number 2. But in the wrong numbering, the substituent is located on carbon number 3. That makes this numbering wrong. And using this approach will lead you to naming the organic compound wrongly. Let's look at our next example. We have this organic compound. We have two options of numbering the carbons in the longest continuous chain. This is actually the longest continuous chain. So let's look at the options we have. We have this option or this option. Which of them gives us the correct numbering? Let's check it out. This is actually the correct numbering. If you look at the longest continuous chain, we have 6 carbons in the longest continuous chain. And this are actually substituents. When we number it this way, 1, 2, 3, 4, the substituents are located on carbon number 2 and carbon number 4. By numbering it from the right to the left, the substituents will be located on carbon number 3 and carbon number 5. 3 and 5 are bigger as compared to 2 and 4, which makes this numbering the better of the two. And numbering it this way will lead you to giving the organic compound a wrong numbering. So this is a practice example. Identify the longest continuous chain and then assign the appropriate numbering to give the substituent the lowest possible numbers. Number 1 and number 2. I'm actually going to help you with the number 1. First of all, I have to identify the longest continuous chain. And it's obvious. 1, 2, 3, 4, 5 is the longest continuous chain. Because this chain is only for 1, 2, 3, 4. So this is my longest continuous chain. Now let me number them. This is the correct numbering. 1, 2, 3, 4, 5. If I number from this way, I give the first substituent number 2 and the second substituent number 3, which when compared to numbering from the down to the top, 1, 2, 3, 4, which will mean that the first substituent will be on 3 and the second substituent will be on 4. So this is the correct numbering. Try this out and write your order of numbering in the comment section. Let's move on to our third step. Identify and name the substituent. There are actually many types of substituents in chemistry, but in this lesson or tutorial, I'll actually be talking about only 2 groups of them. We have the alkyl group and then the halogen atoms. For the alkyl group, the examples we have are methyl, ethyl, propyl, butyl, and pentyl. For the halogens, we have fluoro, chloro, bromo, and iodine. These are from fluorine, chlorine, bromine, and iodine respectively. So it is your responsibility to keep these substituents in mind. But for the alkyl group, one easy way to remember them is by comparing it against the table we earlier saw in the lesson. Realize that if the number of carbon atoms in the longest continuous chain is 1, we have methane, that gives us CH4. But look at this, methyl has CH3. Keep that in mind. If the number of carbons are 2, we have ethane. But look at this substituent, it is ethyl, C2H5. But ethane is C2H6. Propane for 3 carbons. But for the alkyl group, it is propyl. And you can check that for butyl and pentyl. But if you look at their formulas very well, you realize that the alkyl groups are just like an alkane with 1 hydrogen less. So a methane with 1 hydrogen less is methyl. Ethane with 1 hydrogen less is ethyl. Propyl is a propane with 1 hydrogen less. The same thing applies to butane and pentane. So if you are able to keep these in mind, you should be able to remember the alkyl group. Now, in terms of priority, if you have an alkyl group and a halogen atom present in the same molecule, we will have to arrange or bring the halogen atoms before bringing the alkyl groups. Or we start picking more examples that will make sense. Now that we are done identifying and naming the substituent, it is time to move to our last step, step number 4. Assemble the name, the grand finale. And this is a summary of everything we've done so far. So you've done the hard work. You found the longest chain, you've numbered the carbons, and named the substituent. Now it's time to bring it all together into one chemically correct name. Remember to list the substituent alphabetically and attach them to the main chain. Also, if there are a mixture of halogens and alkyl substituents in the compound, the halogens are actually listed before the alkyl group alphabetically. And in naming the compound, numbers are separated from each other using comma, and numbers are separated from names using hyphen. Now is the time for us to pick some examples of organic compounds, specifically alkanes, and see how best we can name them. This compound is the same as this. Now, I'm going to use any of them, particularly maybe this or this, for naming. But how do you think the numbering is going to be done? Check it out. Good. So this is the numbering. So what will be the name of this compound? Check out the name. 2-methylpentane. Why is that the case? The number of carbons in the longest continuous chain are 5. So 5 carbons. We have pent. That's why we have pentane. Now there is a substituent, an alkyl substituent. And if you remember correctly, this substituent is methyl. And where is it located? It's located on carbon number 2. So we have 2-methylpentane. Let's move to our next example. How many carbons do we have in the longest continuous chain? And actually, what is the longest continuous chain here? Let me number it and you see if you were able to get it. So this is actually the longest continuous chain. So we have 7 carbons in the longest continuous chain. And if the carbons are 7, what will be the parent, the name of the parent chain? 7 carbons. So it starts with hept. And we are talking about an alkane. So we have heptane. But we have a substituent here on carbon number 3 and another substituent on carbon number 4. So what will the name be? Try writing it out in the comment section. You can pause the video and write it, and let's see. If you are done writing, check it out and see. 3,4-dimethylheptane. Why do we have di over here? We have one methyl group and another methyl group. So what do we have to do? We have to use di to show that we have 2 methyl groups present in this compound. So 3,4-dimethylheptane. Next example. The longest continuous chain in this example is also obvious, and we have 8 carbons in the longest continuous chain. So the base name will be octane. That will be the base name. But we have some substituent present. We have Br over here, which is bromo. We have one bromo here and another bromo over here. Then we have a substituent here, which is an alkyl substituent. But remember, in arranging the substituents, halogens or halogen atoms are brought before the alkyl groups. So what will be the name? The name will be 2,3-dibromo-4-methyloctane. 2,3-dibromo, because we have 2 bromo over here. So 2 meaning di. And where are they located? Carbon number 2 and carbon number 3. And the numbers are separated from each other using a comma. So 2, 3. And a number is separated from a name using a hyphen. So 2, 3 hyphen dibromo hyphen 4 hyphen. So the hyphens and commas are very important. Number is separated from a number using a comma, and a number from a name using a hyphen. So 2,3-dibromo-4-methyloctane. Now let's pick some practice examples. What is the name of the following organic compound? What is the name of the following organic compound? So the steps you have to follow: first, identify the longest continuous chain and number them. For this one, this is the longest continuous chain, and this is the correct numbering. And then the substituents are located on carbon number 2 and carbon number 3. So name it, write it in the comment section. For this one, the longest continuous chain is 6. 1, 2, 3, 4, 5, 6. It's longer than this particular one. And you see how the numbering is done? We number from this side because this gives us the right numbering. So try writing the name of these 2 organic compounds in the comment section. Let's see who gets it right. So that brings us to the end of this lesson. And thank you for joining us on this lengthy lesson on naming of alkanes.